Your electric bill arrives. You open it, and for a moment, just a moment, you feel it. That quiet, slow burning rage that comes from knowing you are paying for something that was solved 100 years ago. What if I told you that a $2 device, a flat ceramic tile smaller than a credit card, made from a compound first perfected by Japanese engineers, can harvest electricity from nothing more than temperature difference? No fuel, no batteries, no subscription. Just heat on one side, cold on the other, and electricity coming out of the wire. Forever. The global electricity industry generates $2.1 trillion in revenue every single year, and they have spent a portion of that fortune making absolutely certain that you never understand what you are about to learn in the next few minutes. Because the device I am talking about is real. It has a name. It is the Bi2Te3 Peltier TEG module, bismuth telluride thermoelectric generator. And right now you can buy one on the internet for $1.89. $1.89. And it will never stop working. Let that sit for a second. The Seebeck effect, the phenomenon at the heart of this device, was documented in 1821. A German physicist named Thomas Johann Seebeck discovered that when you place two dissimilar metals at different temperatures, electrons move. A current flows. Electricity appears from thin air and differential heat. He wrote it down. He published it. The scientific community acknowledged it. And then almost nothing happened for 130 years, because there was no money in it. In 1834, a French watchmaker named Jean-Charles Peltier confirmed the reverse, that the same junction could also produce a temperature difference when current was applied. Two scientists, two discoveries, the same fundamental truth. Heat and electricity are the same thing moving in different directions. They did not stop developing this technology because it failed. They stopped developing it because it worked too well. Because a device with no moving parts, no fuel input, a rated lifespan of 200,000 operational hours, and a raw material cost under $2 is a catastrophic threat to a system that depends on you paying a monthly bill forever. But Japan did not stop. The Japanese have a word, mottainai. It means do not waste what has value. It is a philosophical principle embedded so deeply in Japanese engineering culture that it became a technical directive. While Western energy companies were lobbying for pipeline rights and building coal infrastructure in the 1950s and 60s, Japanese engineers at institutions like Kyushu University and companies like Panasonic and Hitachi were quietly perfecting the bismuth telluride compound, a crystalline semiconductor alloy of bismuth and tellurium that turned the Seebeck effect from a laboratory curiosity into a production-ready technology. By 1954, bismuth telluride modules were being manufactured in Japan at scale. By 1970, Japanese industrial facilities were using thermoelectric generators to recapture waste heat from exhaust systems and convert it back into usable current. By 1990, Toyota and Honda were running internal programs on automotive thermoelectric generation, attaching TEG modules to exhaust pipes and converting the 900-degree heat from combustion byproduct into electricity that fed the vehicle's electrical system directly. Toyota's internal reports from that era described fuel efficiency improvements of up to 5% in highway driving conditions from exhaust heat recovery alone. 5% from a $2 chip attached to a pipe. The U.S. Department of Energy later estimated that adopting waste heat recovery technology across American industry could save $20 billion annually. That estimate is from their own report. They published it. They did nothing with it for decades. Because $20 billion in savings is $20 billion in lost revenue for someone. The bismuth telluride TEG module, TEC1-12706 in its most common commercial form, contains 127 semiconductor PN couples. That number is not arbitrary. 127 junctions, each one a microscopic engine converting a temperature gradient into electron flow. At 12 volts and with a 68 degrees Celsius differential between its two ceramic faces, this device generates measurable, usable electrical current with no mechanical components of any kind. No turbines, no pistons, no compressors. Nothing moves, nothing breaks. The rated failure rate of bismuth telluride modules in long-term testing is 0.2%. 0.2%. Your phone charger fails more often than that. And here is where the history becomes personal. Because Japan did not just use this in factories and cars. In the ancient city of Osaka, where craftsmen have been working with metallic alloys since the 8th century, The principle of heat-to-energy conversion was practically understood long before Seebeck gave it a name. Blacksmiths noted that different metals in a fire behaved differently, that temperature gradients across a forge produced what they described as a movement force in certain metal pairs. This was not science as Western institutions would recognize it, but it was observation, it was repetition, and it was passed down. The Japanese did not discover the Seebeck effect, but they understood its implications first. And the modern bismuth telluride module is the direct descendant of that understanding, a compound optimized over 7 decades of Japanese material science, now available to you for less than the price of a cup of coffee. If you have made it this far, you already know more than 99% of people who will pay their power bill this month without ever questioning why it keeps going up. Subscribe to this channel and share this video with someone who is tired of being charged for something the laws of physics are handing out for free. Hit the bell, because the next video exposes the specific exhaust configuration that Japanese taxi fleets in Osaka use to generate 340 watts of supplemental current per vehicle, and that information is nowhere else on the internet. And if you want the full protocol, every compound, every wiring diagram, every step-by-step setup for 4 different applications, it is all in the manual. Link in the description. But stay here, because we are about to go from theory to action. A man in Nagoya, we will call him T. Kato, fleet manager, runs a logistics operation with 22 vehicles. In 2019, his operation attached bismuth telluride TEG modules to the exhaust manifolds of his diesel vans. Each van had 3 modules sandwiched between the exhaust pipe, surface temperature 340 degrees Celsius, and an aluminum heatsink cooled by ambient airflow. The temperature differential was consistently 180 to 220 degrees Celsius under highway load. Each module produced approximately 4 watts of continuous output. 3 modules, 12 watts per vehicle. Across 22 vehicles, 264 watts of continuous current fed directly into the auxiliary battery systems. The cost per vehicle, $6. $6. The saving per vehicle over 3 years? Reduced alternator load, reduced fuel consumption, reduced battery replacement cycles, approximately $1,400. The nearest automotive workshop quoted his fleet $280 per vehicle for an alternator efficiency service. He spent $6. They would have charged $280. That is the gap. That is what they are selling you. That is what you are paying for. Now here's exactly how to do this yourself. You need 1 TEC1-12706 bismuth telluride module, $1.89 on Amazon or AliExpress, 1 aluminum heatsink rated for the hot side temperature of your application, $3 to $7 depending on size, 1 tube of thermal paste, $2, a multimeter to verify output, you likely already have one, wire leads, ring connectors, electrical tape, under $2 total. Total investment, $9 to $12. Step 1. Identify your heat source. The exhaust pipe of any internal combustion engine is ideal. Surface temperatures of 200 to 400 degrees Celsius under load. A wood stove flue pipe works equally well. Even a household radiator produces enough differential in a properly staged setup. Step 2. Clean the contact surface of the heat source with sandpaper to 220 grit. You want metal-to-metal thermal conductivity, not paint or rust creating insulation. Step 3. Apply a 1 mm layer of high-temperature thermal paste to the hot side ceramic face of the TEG module. This is the face labeled hot on the module, or the face that will contact your heat source directly. Step 4. Clamp the module against the heat source using a metal bracket or 2 stainless steel hose clamps. Pressure matters. The ceramic face must maintain full contact with the heat source under vibration. Use stainless steel, not aluminum clamps near high-temperature exhaust. Aluminum softens at 250 degrees. Step 5. Apply thermal paste to the cold side ceramic face, the opposite face, and attach the aluminum heatsink. The cold side must remain genuinely cold. If both faces reach the same temperature, output drops to 0. This is physics. Maximize the differential. A small 12-volt cooling fan mounted to the heatsink, cost $3, will maintain cold side temperature and dramatically improve output. With forced air cooling, the same module can produce 2 to 4 times the output versus passive cooling alone. Step 6. Connect the output wire leads to your multimeter. Under a proper differential, 100 degrees Celsius or more, you should see 2 to 6 volts of open circuit output immediately. This is your electricity. You made it. You paid $2 for the physics and nothing for the fuel. Step 7. To charge a 12-volt battery system, connect multiple modules in series. 4 modules in series producing 3 volts each gives you 12 volts at combined current output. Connect to a small charge controller, $8, and feed directly into your auxiliary battery bank or power any 5-volt USB device continuously. The entire setup takes 45 minutes the first time. After that, it runs indefinitely. The word the engineers use is passive, as in, it generates electricity passively, as in, you do not have to do anything, as in, the process does not stop. 200,000 hours. That is the rated operational lifespan of a bismuth telluride module. At continuous 24-hour operation, that is 22 years. 22 years of passive electricity generation from a device that cost $2. Your power company's business model depends on you never reading that sentence. They cannot patent bismuth telluride. That compound has been in the public domain since the 1950s. They cannot create a subscription model around it. Once you own the module, you own it. They cannot generate recurring revenue from a device that requires no consumables, no maintenance, no replacement parts at any regular interval. 3 strikes. 3 reasons it never made it onto a shelf at Home Depot. 3 reasons your energy company has never mentioned it in any communication ever. 3 reasons the automotive industry ran internal research on this technology for 40 years and equipped precisely 0 production vehicles with it for the consumer market. The global thermoelectric materials market was valued at $850 million in 2024. That sounds like a big number. It is not. The global electricity market is $2.1 trillion. Thermoelectrics represent 0.04% of what they could represent if this technology had received the same infrastructure investment as coal. Solar technology, which is fundamentally less elegant than the Seebeck effect because it only functions in daylight, has received hundreds of billions in government subsidy. Thermoelectrics received almost none. Ask yourself why. A solar panel costs $200 to $400 and requires direct sunlight. A bismuth telluride TEG module costs $2 and requires a temperature difference, which is present in every internal combustion engine, every industrial process, every stove, every furnace, every warm pipe in every building on Earth, 24 hours a day, regardless of weather, regardless of season. Sunlight is conditional. Heat differential is everywhere, always. And the Japanese engineers at Kyushu University, who published their research in 2024 in the journal ACS Applied Materials and Interfaces, have now produced next-generation organic thermoelectric devices that harvest electricity from room temperature ambient heat with no gradient required at all. Charge separation at the quantum level. Electrons moving without a temperature differential in the traditional sense. They are already past the version you can buy for $2, and that version already works. There is something almost violent about the simplicity of this. You are surrounded by heat, the exhaust from your engine, the warmth of your radiator, the heat escaping from your walls, the temperature difference between your basement and your attic. Every single one of those differentials contains energy. Physics does not let energy disappear. It only transforms. Every joule of heat that has ever escaped your home unrecaptured was a joule of electricity that your power company sold you instead. They sold you back your own wasted energy. That ends today. If you build this setup and it works, and it will work because this is physics, not magic, not marketing, share your numbers in the comments. Volts produced, temperature differential, setup cost. Every number posted is one more data point that cannot be ignored. One more person who stopped paying for what the laws of thermodynamics make available for free. Subscribe. Share this with someone paying a power bill they are angry about. And get ready for the next video, because we are going to show you the specific multi-stage stacking configuration that Japanese fishing vessel crews in Hokkaido have been using for 15 years to run their onboard electronics entirely from engine exhaust heat during overnight runs. No fuel, no generator, no bill. just $2 of physics, and the knowledge they spent billions making sure you never had.